Mine is the older version. And click on new schematic. Okay, click on the new schematic part. Now we'll take an example of our ISC exam paper. Okay, recently given ISC paper was question number 1. We have to solve and find current through 4 ohm resistance using nodal analysis. Is that right? So let's build this circuit up. Okay, by nodal analysis, then mesh analysis, and find out the value of current flowing through 4 ohm resistance. So I'll recommend that you do along with me what I'm doing over here so that you don't lose the track. So this is my LTspice window. For most of you all, it will be a gray window, right? So what you need to do is go to tools, okay, and then go to these are the settings. You have to do it once. Go to control panel. Please mute yourself if you are joining. Then go to drafting options. Okay. In the drafting options, make the pen thickness as 4. It must be 1 in your case. Okay. Done. Then go to the size can be 28. Now go to color scheme. In color scheme, in the selected atom, select the background. In your case, it will be something different. Make R red, green, and blue as 255 and click on OK. So when you do so, your background becomes white. Okay, I think that should be enough. And if you want to make the wires also black, then what you can do the same thing for wires also. So wires black will be 000. Red, green, and blue should be 000. And then you click on OK. Let me check the lobby. Okay, fine. Up till you're clear, is your background white of your LTspice window? Can you confirm?
So can you repeat what do we
Yes,
do
sir.
from the control plan panel part?
Yeah, go to tools, then go to control panel, then click on drafting options. Under drafting options, check the pen thickness as 4. It must be 1. After that, click on the color scheme. On the selected items, click on the background and make it 255. RGB, red, green, blue, make it 255. Okay. Now, if you want to make something black, that is wires, we can make it RGB, that is green, red, green, and blue as 0. And then click on apply and OK. In my case, it's already been done. So I kept it OK. All right. So all of you got the screen as white now. Can we start? So now right click on the screen, go to view and click on show grid so that this grid is on. Again, I repeat, go to view, click on show grid. So can you see these dots, little dots are there? So that will help us out to for the connections part. Okay. Let me admit some students in the lobby. All right. So are we ready to simulate this circuit? This network for example number 1. All of you together. So now go to components. Click on the components on this toolbar. As you can see, this is the component. Click on it. So here you can type voltage because we require a voltage source and a current source. You type over here voltage. Okay. Type voltage and click on OK and tap it once onto the screen. So it will remain as it is. So you can press on escape so that it disappears. 1. So you have added 1 copy of your voltage source over here. Done. So go to components and type voltage. It will add your voltage source. Now for the current source, type current. So it will add the current source over here. Now if you see the 5 ohm current source in the numerical is opposite direction. So you have to press R, control R. Press control R twice from your keypad and then press on OK and then escape. So that only one copy is done over there. Are you able to do that, everyone? Any problems here? Okay. Can I proceed, everyone? Okay. Let me admit few students from the lobby. Now you need to add the registers. So here is a register directly available over here. Okay, this is a register. Click on it, tap it once, and then again you want it over here. So make the connections as per the given in the diagram. So we require one more over here and one more over here. We can attach it over here. And here we require oriented, right? So for orientation, you can press Control R. It will orient to 90 degrees. So you can place it over here. Okay. So this is the way we can add the registers. So please add the registers in the network. Tap it once and then instead of pressing escape, tap it twice, and wherever you want to add it. So for rotating any component, you press Control R from your keyboard. Done so far? You want me to repeat anything? You can tell me now, or else I said proceed. Okay.
So
Now
can
you
you show
need,
how to add components like the current and voltage?
so go over here and type the current. So you'll get a current source. So this you can rotate it and then tap it onto the screen. So this is the way you can add a current source. Okay. And for the voltage, you can type your voltage and a voltage source will be added over here. Got it? Now, since I have all the components, I need to connect them with the wire. So here is my wire. I can click over it and then from where I want to start, I can tap it once, and where I want to bend it, I can tap it again another time, and then I'll keep on tapping until all the connections have been made like this. Okay. Here I want to connect
Yes.
from here to here. Hello. Yes.
Hello. Sir, how can I move a component after placing it?
You can move a component by this move button. Here, click on it. You can move a component like this. Okay. Okay. Yeah. Where I was with the connection of the wire. So click on the wire. Let's say I want to connect from here. So tap it once, then tap it up till here. It will connect itself. So whenever there are more or one or more wires, there will be a square colored box like this, indicating that the connection is made. Now I will be connecting it here also from here to here. Okay. So my connection in the circuit is done. All of you, please do this connections and keep it ready.
So can you just
Uh,
tell
Can
me
you
how
repeat
do I
how to
rotate the
rotate?
resistor?
Control R to rotate the resistor. What should I repeat? Hello, someone said repeat. What should I repeat? Which step?
Sir, I asked you to repeat the step of how to rotate the resistor, but you said that.
Huh, so you have to,
And should I
let's say,
should I use
let,
controller even for?
yeah,
I was
control R for
asking, should
everything.
I?
Yes, yes. Control R for rotating any register. See, this is the control rotating the register. I'm rotating it. And if you want to delete any component, there is a cut button over here. Click on it. It will disappear.
Okay.
So reach up till here. Then I'll proceed. All right. Can we proceed ahead? Yeah. Now for LTspice, there is a mandatory ground requirement. So you cannot simulate a circuit without a ground. So what you can do is click on the ground over here and place it over here. We know this is a reference ground, right? And then connect it with a wire, the way it is connected in the circuit. Okay. This square color, black color means that it's connected. The wire has been connected. Now after these connections are made, now we have to give the value. So be careful how to give the value. Right click on this voltage source. It will ask as DC value and then enter 6. It's 6 volt, right? No need to enter voltage, is by default taken as volts. Now again, to set the value of this current source, right click on it and enter 5. So it will automatically take it as 5 amperes. Similarly for the resistors, go over here, right click. You can add the value of the resistance over here as, let's say here we require 3 ohms. So 3. Don't click on the R4, R2, R3. Those are the label names. Click on the R part. So R, here you can type it as, or go over here. This is 4 ohms. Right click on the middle of the register. This will be 6 ohms and this will be 2 ohms. So kindly complete this part, or is it completed? All right. Have you completed up till here, everyone? Have you given the values to the components? Any problem in that? So can I go ahead now? Yes. Okay. Now I have to give a label. You remember in nodal analysis, we assign a label A and B or VA or VB. So we'll assign a label over here. So what I will do is I will take out some part of this wire over here. Okay. And I'll press on escape. Then some part of this wire, I'll extend it up so that I can add the label like this. I'll extend the wire. You'll understand why I'm doing tilting on the right hand side. Just a second. Okay. So this is the way I label it. I'll right click on the wire, click on the label net, and I can press over here A and press OK. So A label will be added to the wire like this. And here I'll add, to add the label to the wire again, I repeat, right click on it, click on label net and click on B. So B will be added as a label. Now if I go to zoom full extent, it will fit the screen. So this is the way I have added the label. Okay. So in nodal analysis, first we find VA and VB. Then we find I3, which is VA minus VB upon 4. All right. Completed this step. Okay. I'll presume that you have completed it. Now for simulation, we need to check VA and VB voltage, right? Okay. I have to add someone from the lobby. Please join on time. If you're late, then you can check out the recording for the missteps. I'll repeat this for the one more time for the next numerical. So for simulation, you click on simulate, then click on run. It will ask you which simulation profile you have to select. Please select DC operating point. Select DC operating point and then click on OK. Fine. So when you select DC operating point and you click on OK, you will get the voltages and current values. So V of A, can you see this? If I expand it, V of A is coming out to be 5.5 volt. V of B is coming out to be 8.5 volt. Let's check it from the numerical. Yes, you'd see V of A is 5.5, V of B is 8.5. This is what we get from the solution, right? Yes or no? So our VA and VB is correct. Now, how to check current flowing through the 4 ohm resistance? So current flowing through the 4 ohm will be visible over here, but it will show only the direction correct. I mean, LTspice has a flaw, which I will tell you now. So it will show you 0.75. See, current flowing through is I of R4 will be 0.75. Whereas we got it as how much? Minus 0.75, right? Opposite. So how to get the accurate sign, I will let you know. So first of all, we can note down that it will give you the correct value of voltages. But current, if you want the accurate sign, that is minus or plus, I will tell you how to do it. Right now, the magnitude is correct. I of R4 is 0.75, which is the correct answer. Okay. So
Sir,
everyone
could you
listening?
please do the last part again?
The simulation part.
Yes, sir. How you took the results?
Okay. So go to simulation, then click on the run. All right. So when you click on the run, you'll automatically get all the voltages and currents. So V of A is 5.5, V of B is 8.5. As per the numerical also we got the same. See this VA VB. This document is just to verify your answers. And I of 4 ohm resistance is 0.75. In numerical we got it as minus 0.75. And here we got it as 0.75. So this is one flaw in LTspice, that it will give you the current directions might be incorrect. So to get the accurate current directions, I will let you know how to do it correctly. So you got the results now. Any problem in that? All of you are getting this values 5.5, 8.5, 0.75. All right. Now the direction of the current was not proper. So to eliminate that, okay, what you need to do is you need to add a, first of all, what I will do is I'll move this part, entire part, B part. See what I'm doing. I'm moving this part to the right hand side. Okay. I repeat again. I'll do undo. So I'll move this part because I'm adding something over here. So I go to move button. I select a rectangle over here like this and I move on to the right hand side. Just align, perfectly aligned to this. Then I'll connect this ground part as it is. And wherever I want to add, I want to measure, how do you measure a current in actual practicals? You add a ammeter, right? So in LTspice, there is no ammeter. I will be using a voltage source. I will be using a voltage source as ammeter. Rotate the voltage source like this. If I assume the direction of current from left to right, it should be plus minus from left to right. So I'll add this voltage source over here. Then connect it with a wire like this. I'll call this voltage source as Vx. Okay. And I'll give a 0 volt to it. I have to give a 0 volt voltage source. So here, this 0 volt voltage source will act as my ammeter. Okay. So let me complete it. Then I'll repeat again. So if I now simulate again, run. Okay. Now instead of measuring the current through I4, I'll measure the current through this 0 volt voltage source, which is my ammeter. This will show me accurate direction as well as the magnitude of current. So what is the original current with what we want? Minus 0.75 amperes, right? Current flowing through 4 ohm resistance was minus 0.75. So here if I simulate and if I check I of Vx, what is the current flowing through this 0 volt voltage source is minus 0.75. So this will give me the correct answer. Alright, understood? So shall I repeat this step or this step is clear?
Sir, the naming of the voltage source is coming as V2. It's okay now?
Yeah, but don't give it any V2, V1 or something. Make it as Vx so that is distinct. Because it's a test source, actually, there is no ammeter in LTspice. So we make use of 0 volt voltage source as a current meter. So that's why rename it as Vx only so that we distinctly found that it is only used to measure the current. That's it. It has no use in the circuit, right? 0 volt is not adding anything. It is only used to measure the current. So yeah, naming convention, you can name it anything, but it's preferable that you name it distinct. Let's say Vx. All right. Understood this? Do you want me to repeat anything? Or, I mean, I've done with this numerical. We got the answer as minus point.
So, when you
Yes.
said to make the circuit and then run it using the simulator,
Yeah.
whenever I'm trying to click on the run option, it's giving me things like configure analysis, transistance,
Yes,
AC
yes, yes,
analysis, and
yes,
stuff.
yes, yes. Wait, 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 wait. So you are getting this right. Let me remove this so that I can show it to you. So if you go to run, click on the run, you get this and this screen, right? So from here,
Yes, sir.
you have to click on DC operating point,
Okay.
this one, and then click on OK.
Okay.
So dot .op will
Okay.
be added as well as you will get the screen. Did you get the results now?
Yes, sir.
Okay, yeah, that is the way to do it. And we got the answers VA, VB, and VI of Vx as correct value. So you want me to ask anything, you can ask in this, or else I'll move on to the next analysis. So until I hear in this numerical, you can ask me. Now, one thing additionally with what I can say is you can right click. Everyone has to add their name and roll number. So what I will do is go to draft and go to comment. And here I can type my, let's say my name I'm typing over here. Okay. And I want to add my roll number. I will add my roll number, let's say like this onto the screen. And this numerical is a nodal analysis. So I can press Control M to go into the next line. So we can write here nodal analysis like this. So like this, I can add my comments onto the screen. Okay. And if in the exam, if in your, IA number one, if it is asked to attach the print screen, then what you need to do is click on the zoom full extent, add your name and your roll number. You add the which analysis you have done and add the results screen also together. So let's say this is my result screen. So what I will do is I'll push the entire screen on left hand side, my simulation, and I want to see the results also together. So I can adjust the screen. See, I can adjust the screen. Okay, I can place it over here. I can maximize this part by the scroll button on your mouse or in your laptop tap screen. I can increase or decrease this. All right, and then I can take a print screen of this. To full print screen, you take it please, so that the time and the date is also recorded. Then I'll go to a document. Let's say if I want to add the print screen over here like this. So your print screen should be visible very, very clearly like this. So this way we can check your name, your roll number, your results all together on one screen. Is that clear to you? So you need to add such print screens for your results. Okay? Understood how to add the
So
results?
what do I do when it says no request for analysis found?
Um, no request for analysis. So just a second. I think you have to reinstall your LTspice in that case. It might be some corrupted version. So you have to go over here, DC operating point. Did you click on OK? And did .op came
Yes,
to your
sir, I
screen?
did.
Did .op
No,
came
it
to your
said
screen?
no. It directly showed me a pop-up saying that no request for analysis found.
So, I mean, you can share your print screen, what problem you are facing in email. I'll reply to that, or else you have to reinstall your software, LTspice.
Okay, sir. Thank you.
Okay? Yeah. So everyone understood how to take the print screen and attach it as a part of your answer this way. All right. So now we
Sir,
move on to the, sorry.
it is not working on Mac, so do we have to do it on Windows only?
No, no, it works. It has a Mac version also.
Yes, sir, but it is showing a blank screen and no functions are available.
Blank screen in a sense, you have to click on run, and then did you select the um,
No, sir, means there are no commands available, only wait. Sir,
um, I have not referred to the Mac since a long time, so I am not sure how to solve that. If you can do it on Windows, if you have Windows, then you can do it on Windows also. Okay, okay.
okay.
And I think in Mac, last time a few students have done it in the MacBook, and they got the results properly. I don't know why. What is the problem now? Maybe if you can also share me your print screen, I can help you out in that.
Okay, sir, okay, sir.
Or you could try reinstalling the software once.
Okay, sir.
All right. Now, you remember in this question number 1, we have to solve by mesh or nodal analysis. See, in your IA number 1, it can be anything. It can be mesh analysis, nodal analysis, or theorems, Thevenin's, Norton, superposition, maximum power. So out of these 6 only, the numerical question will come. So I'm teaching you all one by one. Now, I will go to mesh analysis. So for mesh analysis, what do? We find the current I1, I2, I3. Correct? Yes or no? So there is no nodal analysis. So I'll change the existing circuit only to mesh analysis. So how to do that? First of all, I'll remove this. This is not required, no longer required. Okay. I have to do the mesh analysis now. So I'll change this to mesh. I should get the same answer, by the way. Okay. By mesh analysis also. Yes or no? So I want I1, I2, and I3. I want to view I1, I2, and I3. Yes. So if I want to view any current, how do what I have done over here? Added a 0 volt voltage source over here. I've added. So similarly, you can add it over here and add it over here also. 0 volt voltage source. I think lot of y'all who have checked your papers have got this I3 as wrong. I3 and 5 amperes current source was opposite direction. That is why it came out to be negative. And many students made a mistake over here and lost their marks. So I want to show you all why I3 is negative over here. So that means we have to add 3 0 volt voltage sources, one over here, one over here, and one over here. Although I will get the answer with this also, but still I want to show you all I1, I2, and I3. All right, can we start? Everyone ready? Okay. So I want to add a current source over here. A current meter, which is a 0 volt voltage source. So I will add it over here and add it over here. So for that, I'll move this entire circuit from this side like this. Okay. So that I can add my voltage source. So here I've added a voltage source like this. Oh, let me select a voltage source. Here is my voltage source. And I want the current to go from left to right. So I'll add it like this. Okay. So this voltage source, I name it as VY and I give it a value as 0 volt. So this VY will measure I1, Vx will measure I2, And then I require one more voltage source over here, 0 volt voltage source. So I'll click it over here. Then I'll add again a 0 volt voltage source like this. I want the current direction to go from left to right. So I've added plus minus from left to right. Okay, and then I'll join the connections here. Okay, so VZ will measure, this is 0 volt. VZ will measure I3. So I1, I2, I3 means the current flowing through VY, VX and VZ. Let me make this as VX so that it becomes in consistency. This is Vx, this is Vy, and this is Vz. So current flowing through Vx will be I1, current flowing through Vy will be I2, and current flowing through Vz will be I3. All right. So after doing this, I'll click on simulate, run, and I got all the values over here. Let me check it if it is correct or no. Okay. So by solving, you got the value of what was I3. You can check it over here. I of Vz will be I3. See, I of Vz. Here is I3, which is minus 5. So as predicted, I of 3 is minus 5. Okay. Then you got the value of I1. I1 was I of Vx, like this. Can you tell it is correct or no? 1 by 6 is 0.1666, right? Is it
Yes, sir.
not? And what is I of Vy is I2. See, I think 3 by 5 is 0.75 minus 0.75. Yes. So I2
Yes.
is minus 3 by 4, which is 0.75. So here you see, you get all the accurate values of current, magnitude, as well as direction, if you do it this way. All right. So this is the way you can do your mesh analysis. Now to add your results, let's say you want to attach your results to your screen. So what you need to do is maximize the screen, click on the zoom full extent, slightly minimize it, keep it on the left hand side, and then simulate. Then adjust this window so that it fits the screen. Then you can maximize or minimize the screen. Yeah. And this way you can add your results this way. Okay. So these are very clearly evident that I of Vx, I of Vy and I of Vz is my three currents. Then I can press print screen. Take the full print screen. Don't crop it so that the time and date is visible. Add the print screen and attach it to your document. So this next is for your mesh analysis, giving the same result. Okay, this was nodal analysis, this was mesh analysis. Understood? So this is the print screen which we will view it. So we can check the, results very carefully over here. Your name, your roll number, your results, all of them together, and the date and time is also visible. So this is the way you can add your print screen. So we have completed mesh and nodal analysis. Next, we will go for your Thevenin's theorem. Any doubt up till now, you can ask me or else I'll proceed. Because now I can increase my speed a little. Any doubts, anyone? All right. So now we go for next numerical. Yeah, we go for superposition. Is it fine? Superposition is fine. So we'll go for superposition theorem because that is also a part of it. So using superposition theorem, find the voltage across 4 kilo ohm resistance. So I'll go to the new schematic. Okay, new schematic. Then let's build the circuit together. So this is my circuit given to me. I slightly minimize this part. Okay, so go to components. So I'm repeating the steps, those who have joined late. So please listen carefully. For adding a voltage source, I will type over here. First of all, I'll go to components and click on voltage. Okay, then I'll click on OK. It will add a voltage source onto the screen. I'll tap it once. If I want another to rotate it, I can rotate it over here like this, and I can tap it one more time. Now third time I don't want it, so I press escape. All right. Now if I want to add a current source, I'll type over here current. And now I want that the current direction is opposite. 10 milliampere is upwards. So I'll press Ctrl R to do that, and I'll tap it onto the screen. So I've added my voltage source and current source. Now I require resistors. So for resistors, I'll go over here, tap it once. Here I'll have to rotate it. So I've tapped it once over here. I rotate, press Ctrl R, and I require one more over here. So I've tapped it another time here like this. So I've added the resistors and all the components. All right. Now I will just move this a little up so that the circuit becomes neat and clean. Now I have to add them with the wire. So I click on the wire. If I start from here, I'll tap it, and I want to bend the wire over here. I can tap it once more time. Tap whenever you want to bend, and then connect this circuit as it is. Then this wire will go over here. Can I make the circuit as per your circuit diagram only? Make it look like that. Okay. So all the components and wires have been connected. Now it's very important to add the ground. So here is the ground given to us. I'll connect that with the wire here. Now the next part is to add the to label the these things, to add the values of each components. So right click on the current source, give it 10 milli, 10 M. Amperes it will automatically understand 10 milliamperes. R2 value is 1 kilo ohm, so 1 K. You can add 1 K. Here it is 4 K. Okay. Then I have the value as 15 volt. Here it is 25, and this is 3K. So now I've added all the component values as 10 milliampere, 4 kilo ohms, 1 kilo ohm, 3 kilo ohms, 25 and 15. All right. So let me know when you're ready. Are you following how to add the components and their values and connect them with the wire? Any doubts over here, you can ask me. Anyone having any doubts? Okay. Can I go to the next part now? So we have to find, using superposition theorem, find the voltage across 4 kilo ohm resistance. Okay. So that means I have to find the voltage across 4 kilo ohm resistance with respect to ground. So this I can do it directly without solving superposition theorem also, but we will be solving by superposition theorem. So I know the final answer is how much? 28 volt. Final answer is 28. So I can directly get 28 volts directly over here. Okay, how you know? Whenever I want to find a voltage across a resistor, I have to label that, this node. Let's say this is with respect to ground it is giving. So I'll attach a wire over here, and I label this node as, let's say, VA. I'll name it as VA. That's it. So it will give me V of A. So V of A is nothing but V of 4 ohm resistance, 4 kilo ohm resistance with respect to ground. So now what I will do is, now I'll go to simulate, click on run, click on DC operating point, then click on OK. So what I got V of A as how much? Can you see this? 28. So 28 was the final answer, but so this is the final answer is 28. I'm not used superposition theorem. I directly got it as 28. This is just to check it whether it's coming or no. Okay. Yes. So what I will do is I'll place it over here. I can add a label over here by going to draft comment. So this numerical is on superposition theorem. You can add your name and roll number that you can. I already told you all how to do that. So I'll just shift it over here. I want to view the final result. So I'll click on run, I'll add these points over here and I can mark this to indicate that voltage flowing through 4 kilo ohm, voltage across 4 kilo ohm is 28. And I can put it to full screen mode. But this is direct answer. This is not using superposition theorem. I have to prove that it is using superposition theorem. So for superposition theorem, I'll do the following. Are you with me? Any doubts you have? Can someone reply? Everything is going fine. You are able to understand this? Because the feedback from y'all is important, or else I'll go slow, little fast. Is the pace okay with y'all? Hello?
Yes, sir.
Okay, if you are able to follow, then fine. Now I will have to do three cases, right? So I will find V4 dash, V4 double dash, and V4 triple dash. So first case will consider 10 milliampere current source only. Remaining current voltage sources will be short circuited. Okay. Then I'll find a value of 15 volt voltage source, V4 double dash, and then 25 volt voltage source only I'll consider. I'll find out V4 triple dash. Okay. So yeah, this is what I will do. This is my plan. So first of all, for 10 milliampere, what I will do is I will copy the entire circuit again. So there is a copy button over here. I'll click as a rectangle. I'll select the entire thing again and place it over here. Okay. So what I did was I added everything and placed it over here. That's it. I'll change this label to VB. Okay. And then I'll do the same thing for the third time. For the second time, I'll copy this entire circuit like this and place it over here. Okay. So I've added three circuits of same. Here I'll give the label as C. Okay. So you understand what I'm doing first. First of all, here I'll add the label as I'm only considering 10 milliampere current source. So only this is considered. 10 milliampere current source is visible. Okay. The next part, what I want is 15 volt voltage source. So here I'll write 15 volt voltage source alone. 15 volt voltage source here. And here it is 25 volt voltage source alone. Remaining circuits I'll short circuit. So here I'll add 15 volt voltage source. So what do we do over here for 10 milliampere current source? For 10 milliampere current source, we consider only 10 milliampere. Remaining we deactivate. How do you deactivate a voltage source? Anyone, any idea? How do you deactivate a voltage source? Come on. You have learned in your theory, right? How you deactivate a voltage source? By short circuiting it, right? And how do you deactivate a current source? By open circuiting it. So here I'll remove them with the wire. I mean, remove them with a cut and add a short circuit like this. Okay. So this value will give me V4 dash. V of A will give me V4 dash. Okay. So here I'll consider 15 volt voltage source. So only 15 volt will be active. Remaining this 25 volt voltage source will be replaced with the short circuit like this. And I'll open the 10 milliampere current source. So this will be open circuit. All right. So this V of B will give me V4 double dash. Okay. Then I'll come to 25 volt voltage source. So for 25 volt voltage source, 15 volt voltage source will be replaced with a short circuit. And this milliampere will be open circuit. So here I'll replace it with a wire. So this V of C will give me V4 triple dash. Got it? So I have three circuits. Independently, I'll consider one source at a time and I'll get the values. Yes or no? So now
Sir,
I'll simulate. Yeah, let me complete it. Then I'll address the queries. I'll simulate. I'll run. So I get VA, VB and VC together. So V of A, see V of A is when 10 milliampere source is active. Let me check the answer. So V4 dash is V of A, right? It is 8 volt. See, it is 8 volt over here. Okay. So for the next part, case 2, Case 2 is what? 15 ampere source alone. So 15 ampere source means V of B. See, V of B is 0. See here, V4 double dash is 0. So V of B is 0. And for V of C, which is V4 triple dash, I'll consider 25 volt voltage source alone. So V of C should be 20. Is it 20 coming? Yes, it is 20. See, V4 triple dash. Now, as per the superposition theorem, we will add V of A plus V of B plus V of C, which is 28. Got it? So this is the way we get the result of the superposition theorem. Okay. So now I'll address the query. Let me push it over here. Then I'll simulate, click on the run. Now I can add the results here very carefully. And here you can clearly say V of A is V4 dash is 8 volt. V of B is V4 double dash, which is 0 volt. And V of C is V4 triple dash, which is 20. So if you add them together, you will get it as 28. Yeah. So this I can print screen it and attach the result over here. Will prove my superposition theorem. See this, it will clearly show superposition theorem. So directly we were getting 28, but this is not the method we have to use. We have to use superposition theorem. So I've added 3 circuits, one source at a time I'll consider, and I got the value of 8, 0, and 20 directly as per your result. Yeah, now you can ask your doubt.
Sir, how did you add the 10 milliampere in the first circuit and 15 volts?
So you have joined late or what?
No, sir. I was trying, but there was a weird connection happening. That's why. Could you just repeat the part?
Components, current source.
सर नहीं वो हो गया sir. In the later part you divided it into 3 circuits and then you added 10 mA above the circuit, right?
No, I didn't add. It was already there. 10 milliampere was already there. See, if I want to add, if I copy the circuit like this, see, there is a copy button. I can select the entire circuit. Everything gets copied out. It's not that I've added later. I've added earlier only.
Okay, sir.
So I made the circuit together with all the sources. Then I've added them 3 parts. I've copied 3 parts, and then I've removed one by one the voltage source, current source as per the requirement. So for the 10 milliampere case, only 10 milliamperes is adding. Rest 2 were voltages, so I've short circuited them. For 15 volt voltage source, 25 volt voltage source is short circuit, and 10 milliampere current source I've removed it, open circuit. So this is open circuit, this is short circuit. For 25 volt voltage source, 15 volt was short circuited and 10 milliampere were open circuited. This is the normal procedure, right? If you have doubt related to LTspice, you can ask me. Even if you have a doubt in superposition, you can ask me, no problem. But this is the method. We already got the answer similar to what was there in actual numerical. And we got the final answer as 8 plus 0 plus 20, that is 28. If you have queries, further queries, you can ask me, or else I'll go to Thevenin's Norton's theorem, which is the last part. Okay. Do you have any doubts further? You want me to repeat anything or something? Okay, fine. I guess that's fine. So now I'll go to the next numerical, which was in our numerical Thevenin's theorem. Okay, we have to find the current flowing through 30 ohm resistance. So I'll click on the new schematic. This is important Thevenin's theorem and Norton's theorem. I'll show one example for both. Okay, yeah. So this is my circuit. I have to build the circuit in LTspice first. So listen carefully. Go to components, type voltage over there, add 2 voltages, one over here, and I can one probably over here. Okay. Then I have to add current. I'll go over here, type current. Now this orientation of the current is slightly different, so I'll press Ctrl R. So I've added the current source over here. Now I have to add the remaining resistors. So this is resistor number 1. Then I'll to press Ctrl R to rotate. Add the 3 resistors over here. 1, 2, and 3. Okay. So all the components I've connected. Now I'll connect it with a wire. So wire, I'll tap it once like this. If I want to bend it, tap it another time. Tap here again and tap here again. Complete it. Now I have to connect the wire over here also like this. And I have to add a wire over here also like this. Okay. Now it's mandatory to connect the ground. So ground is over here like this. All right. So now I'll give the values. So right click over here. This is 150 volt. This is 15 ohm. You can see the right hand side circuit. This is 60. This is my RL, which is 30 ohm. This is 40 ohm. And this will be 50 volt. All right. Current is 13 amperes. So I've given all the values and I've given the ground. Now the question is find the current through 30 ohm resistance using Thevenin's theorem. But LTspice can directly give me the answer. You want to know how? So how do you measure the resistance? How do you measure the current? What technique did I tell you? Can anyone tell me? How do you measure in current in LTspice? Come on, we have done it twice. Hello. How do you measure current? So what we do is we'll push this on the right hand side so that we can add a, let me add a voltage source over here. So add a 0 volt voltage source to measure the current, right? So I'll add the voltage source. I think it's added twice. Yeah. I'll make the connection. So this current source should be coming in series. This 0 volt voltage source. The value is 0. We call it Vx. So current flowing through Vx is my I of 30 ohm resistance. And current flowing through 30 ohm resistance. Okay, it should give that way. That is what we have learned today, right? Now, if I simulate, I'll directly get I of 30 ohm. Let me show it to you. I'll click on OK. I of 30 ohm. So I of Vx is 1.240248006, right? This is the answer I got. So let me check by superposition. So by Thevenin's theorem, I'm getting this answer. Yes. See, I of 30 is 1.2480. I'm directly getting the answer. This is not the way to do it, but I can directly check my answer for quick calculations. Yes. So what I can do is I can add this in the screen. I can click on right hand side. Then I can call it as a Thevenin's theorem. Go to draft. Go to comment. That is Thevenin's theorem. I'm getting the result directly here. So I can serve it as a example that this is what I should get at the end. So I of Vx is my actual current flowing through 30 ohm resistance. So I can add a print screen and then I can add the print screen over here. So I know the final answer. Now I have to follow the procedure of Thevenin's theorem. So what is the final value I got it as? Theoretical value 1.24806. Theoretically I got 1.2480 amperes. This is what I got theoretically, right? Let me write the theoretical values first. How much VTH I got? 26.0869. 26.0869. This is what I got in ohms, right?
So
So
that's
let me,
RTH.
yeah, RTH. I'll place it in RTH. Sorry. This is RTH is 26.08. Yeah, thank you for pointing out. That was RTH 26.0869. I'm referring to the solution of ISE. Everyone has it, right? Then VTH came out to be 70. So VTH came out to be 70 ohms, 70 volt. Got it? So I have the result over here. So what you will do is, if it is asked in your IA number 1, you have to solve a numerical. Let's say this is my numerical, and get the value of VTH, RTH, and IL, and put it tabulate it in a table form like this. And then by simulation, you have to verify the same thing. So by simulation end result, I'm getting it correct. That is, I of IL is current flowing to 30 ohm is 1.24806. So this is correct. 1.24806. I'm getting it correct. So remaining things also we need to verify VTH and RTH. Got it? So I'll go over here. Let me save this. I'll go over here into the screen. Now I have to measure VTH and RTH. Do you know the procedure? What do we do in VTH and RTH? First of all, I'll copy the circuit twice. This is once. Why twice? I'll let you know. One for VTH circuit, one for RTH. So again, I copy the same circuit. Okay. So tell me, what do we do in VTH? So this is for VTH. Theoretically, how do we calculate Thevenin's voltage? Can someone tell me? Okay. What procedure do we follow? We remove RL, right? Yes or no? And we measure VAB, which is or VTH directly. Yes or no? That's the procedure. So where is RL over here in our circuit? This is VTH, right? Calculation. So where is RL over here? RL is this, and these points are called as A and B. So I'll first of all delete this 30 ohm resistance along with the voltage source. This is gone. I will call this as let me call this as VA, and this will be VB, and I should label this as right click, label net A, and this I'll call it as B. Okay, so now if I simulate directly, VTH will be your VAB. Directly I'll get the answer. I'll do that later. Just wait. VTH. Let me show it to you if I can get the answer. VAB. VAB. Okay. Do you see V of A anywhere? Okay, here it is. V of A is how much? 120. V of B is how much? 50. So V of what is V of A minus B? 120 minus 50. How much it is? Anyone? 70, right?
70, yes.
Yeah. See this VTH 70. So here I can write it over here. I got the results, right? I can highlight them over here. I can press Control C to copy them. I can write it below over here. In the comment part, I got these results, right? Here. So V of A minus V of B is VTH, which is 120 minus 50, which is 70. So this is how I measured VAB or VTH. So here you can write it down in the next step. VAB is equal to V of A minus V of B. You have to write it exactly in the same fashion, whatever the circuit is 50, which is 120 minus 50, which is 70 volt, which is equal to RTH. Sorry, VTH. So this is the way we can write the result for Thevenin's voltage. Understood? Any doubts over here? I removed RL and measured the open circuit voltage between terminals A and B. That will give me the value of VTH. So VTH came out to be correctly as 70 volt. The solution is in front of you. Then I can do for RTH. Do you remember what we do for RTH? Procedure in theory. Thevenin's resistance.
We short the voltage sources and open the current sources.
That means we deactivate all sources, right?
Yes.
We
Yes, sir.
deactivate all sources. We remove RL also, and we measure RAB or RTH. So this is what we do for Thevenin's resistance. We deactivate all sources. That is, if it is a voltage source, we we short circuit it. If it is a current source, we open circuit it. So first of all, let me remove RL. This was, see this. I'll go back over here. This was your RL. So I have removed it. Then any voltage source connected, it will be short circuited. So I removed it and replaced it with a wire here. Then there is one more voltage source. I remove it, replace it with a short. Then I have a current source. I remove it just and keep it open like this. Okay? Yes or no? Now I have to measure RAB. Unfortunately, there is no device which will measure resistance directly uh, for a circuit. So how do you measure resistance? Do you know Ohm's law, right? What is Ohm's law? Oh, sorry. Ohm's law says that, let me add a comment over here. So voltage is equal to I into R. So can I find R if I know the voltage and current? So voltage will be, resistance will be V by R. Resistance will be V by I. So this is the way I will do it. I'll add a known test source over here and find the current through it. So what I will do is I'll add a voltage source over here, any value. Let's say I'll connect it like this. Okay. I'm deliberately adding a voltage source over here. I'm calling that voltage source as V, let's say Vx. Okay, I'll give it a different value. So it should be, let's say, anywhere 10 volt. Okay, and now the current flowing through this voltage source, if I found out, then I divide this 10 volt divided by that current, I'll get RTH, directly resistance. You want to see what I'm saying? Here it is. So if I simulate this, I'll search for V5, I of V5. So I of V5 is showing me, only consider the magnitude of it. Huh? Maybe we have connected the voltage source opposite. That's why it's showing like this. So I of V5, you note it down. How much it is? Okay. I of V5, I noted down. So here it is. But forget about the current direction. Okay. Only consider the magnitude. So now tell me, how will you calculate RTH? So RTH will be V5 divided by current of V5. Magnitude, magnitude only. So this is 10 volt divided by 0.38333. Can you tell me, can anyone calculate this and let me know how much is 10 divided by 0.388? Can only consider the magnitude. How much is this? 10 divided by 0.388?
26.089.
089 directly?
Yes, sir.
Okay, fine. So this is what we get. See this? Isn't it the value of RTH? See? So what we did was, over here for RTH, we added a known value of voltage source. Now one will argue that why 10 volt? I can give 1 volt also. Yes or no? So if I give 1 volt, my answer will accordingly change. See, I of V5 I will search. See here. So for 1 volt, I'm getting 0.038. So 1 divided by 0.038 must be again 26.089 only. Correct? So you added a known value of voltage source and measured the current flowing through it. Only consider the magnitude. Resistance is never negative. Okay. It's coming negative because you have connected the supply not in the proper orientation. So this is the way we can calculate RTH. Any doubts? So this is the way you have to calculate RTH. And then what do we do at the end? We make a Thevenin's equivalent resistance or Thevenin's equivalent circuit. So what is Thevenin's equivalent circuit? A voltage source in series with a resistance, right? And then we connect back your RL. Yes or no? So this is RTH. This is VTH directly. And this is your RL. Okay. Now let me join them together. This is my Thevenin's equivalent circuit. Before I forget it, I'll write down Thevenin's equivalent circuit. This is Thevenin's equivalent circuit. Of course, you have to connect a ground. So I'll connect the ground over here. Measure it with connect it with a wire. Now I'll give the value. What is VTH we got? 70. Correct? How much is RTH we got? 26.089. And how much RL value was? 30 ohms. Remember, we did exactly the same way, right? Then we measured the current in the circuit. How do you measure the current in the circuit? What technique you have used? Tell me. You push this around over here. Add a 0 volt voltage source. This is to measure the current only. Okay. I'll select this. You add a 0 volt voltage source which will act as an ammeter to measure the current. That's the only deal for us adding this 0 volt voltage source. Then I can call it as a 0. Have I used Vx before? So this I'll call it as Vy. Vy. Now this current, whatever I of Vy is, should be my IL. Okay. If I simulate, run, search for I of Vy. How much it is? Can you tell me? I am not able to. I of Vy, how much? I of Vy, I of Vy. Here it is. How much is I of Vy? Can you see? 1.248. Let me add it over here. This is the value of current which I get. And that is equal to what? Load current, IL, which is 1.24802 amperes. Isn't this my answer? Yes or no? This is the way I found out theoretically also, right? So last step I found out that Thevenin's equivalent circuit, see this. See this circuit and see this circuit over here, which we have made. See VTH, RTH, and RL. Then what value you got? 1.2480 something. Correct? Yes or no? So now I'll go back to the how do I share these results? I'll tabulate the results over here. VTH we got it as 70 volt only in simulated value. RTH how much did we get? How much did we got? 26.089 ohms. 89 we got, right? I heard that correctly, right? Yeah. And how much did we get the load current? Load current by Thevenin's equivalent circuit is 1.24802. So yeah. So these are my simulated results and these are my theoretical values. Now which all diagrams we have to include? See, we did this everything together. Yes or no? So you can do it individually, you can cut and paste, or I can just click on simulate, run. I already got all these values. So you can paste the results separately, or else I can move this a little circuit over here. Slightly I can shift it over here so that I can add the results here only, here itself. Okay, so now if I simulate, click on run, I can add all the values which I can see over here together. Here they are from here, this side. So all these results are useful. I can do a print screen. All of them are together, or you can do it separately also. And I can add this print screen over here to confirm that I did my Thevenin's theorem well. And all these results, we will check it from here, and we'll check it from the table if they are matching or no. If they are matching, you will get full marks. If it doesn't match with your theoretical value, your marks will be cut. So basically in your IA number 1, 5 marks are devoted for theoretical values, 5 marks for simulated results along with the proof. Now this is the proof, right? That you have done Thevenin's theorem perfectly well. Are you understanding? Do you have any doubt in this now in Thevenin's theorem? We have done the complete theorem, measured the value of VTH, then RTH, then Thevenin's equivalent circuit, and finally found out the value of load current IL. Do you have a doubt over here? You will require practice, huh? You have to solve this, might be the same numerical afterwards, or if you're solving along with me right now, well and good. Now only one last thing is left. Instead of Thevenin's theorem, we'll also solve for Norton's theorem. So I'll show it with the same example only. Okay. So any doubts so far over here? You can ask me right now before I proceed. So I can solve same numerical by Norton's theorem also. No problem. Anyone having any doubt? Please let me know. Can I proceed? Can you give a confirmation that you have completed this? And can I proceed to the next part? That is last one, which is Norton's theorem. Can someone confirm, please, verbally? You all are following whatever techniques I am teaching you all for LTspice to measure the circuit current and voltage. You all are there along. Hello. Yes, no. You got the same results as mine shown in the screen. You can check, of course, check the recording later.
Yes, sir.
All right, great. Okay. Yeah. So for the same circuit to measure as a Norton's theorem, I'll do the following changes. For Norton's theorem, you remember RTH was same, so RTH will come same only as it is. Of course, we don't have this Thevenin's equivalent circuit, so Thevenin's equivalent circuit I'll remove it completely along with the result over here. And this Thevenin's equivalent voltage also we don't have it, so I have to remove this circuit also. Here it is. So let's solve this by Norton's theorem. So if I solve by Norton's theorem, okay. So what will be Norton's theorem? Again, we have to find the current flowing through. Please mute yourself if you're not speaking. So by Norton's theorem, I want to find the current flowing through 30 ohm resistance. Here it is, 30 ohm resistance. So what I will do is for Norton's theorem, we calculate short circuit current. So I'll add over here short circuit current like this. I'll add the circuit as it is. Remaining RTH is same. So let me show it for Norton's current. So this I'll change it accordingly. We find IN, which is Norton's current in the same numerical. You should get the answer same. We don't remove, we remove RL and replace it with a short circuit. Yes or no? That means we short circuit A and B terminals. Short circuit A and B terminals. Then we measure IAB, current IAB or IN, Norton's current. That is what we do. Okay. So which are my, this is my RL, right? I'll remove this RL. So this is my terminals A and B. Okay. So normally we short circuit it, right? Like this. But I want to measure the current through this, two terminals. This is A and B terminal. So how will I do it? In order to measure the current, what we do normally, we add a voltage source, 0 volt voltage source. So here also I'll add 0 volt voltage source directly. All right. Of course, these are my terminals A and B, so I can label them still, but it will not be helpful for labeling them because it's the current which I'm interested in. So these are the two labels A and B. So if I want to find the current source, I'll give a 0 volt voltage source. So this is V, let's say Y. So if I simulate the circuit now, it will give me short circuit current through A and B, and ISE or IAB or IN will be the current flowing through VY. Okay, understood? So this will be current flowing through V of Y will be IN. I don't know its values yet. I'll just simply take it the word for the LTspice. So I have to search for I of N, I of VY. I of VY is coming out to be 2.6833. This one. So I'll copy this down and note it down. Maybe I'm getting this value. We have not solved this, but the final answer should be same. Here it is. So I of Vy is my Norton's current. So I can say it is Norton's current, which is 2.68333 amperes. Maybe it's the Norton current, maybe not. Now, last step, we have to draw a Norton's equivalent circuit. So Norton's equivalent circuit, we consider a current source. So this is my current source. Then I have IN, this is RN or RTH. Then I have RL. Yes or no? So this is IN, Norton's current. This is RTH or RN, which is same as RTH. And this is RL. Okay, how much is the value of IN? 2.68333. How much is the value of RN? It's 26 point. It's the same as RTH, right? 0.89. And how much is the value of RL? 30 ohm. Now I'll connect them together. This is Norton's equivalent circuit, okay? By the way, final answer should match. Okay. So I want the current flowing through RL. So what I will do if I want to find the current flowing through RL, I'll just add a voltage source. So I'll add a voltage source over here, 0 volt voltage source. Just have patience. It's the last numerical for the day. So I connected it over here for Norton's current. This is 0 volt. This is VZ, let's say. So current flowing through VZ will be my IL. Okay. Of course, I have to connect the ground over here. So what is this circuit called as? This circuit is called as Norton's equivalent circuit. Norton's equivalent circuit. Okay. Now if I simulate this, I of VZ will give me the actual current. I of VZ, where it is? Yeah. See this? I of VZ over here. See here we are getting 1.2481. So is that the actual current we got it from the Thevenin's theorem? Yes. Yes, we got the same current. Okay. So here let me add that value over here. I of Vz. This is the current we got. So I'll add it in a comment over here. So this is my total load current by Norton's theorem. So IL is 1.24811 amperes. All right. So we entire circuit we solved it by Norton's theorem now as it is. So I can do this, place it all together, run it, and then I can place this values over here directly for your print screen. So this is by Norton's theorem. Let's say if you want to solve this numerical by Norton's theorem, these are all the values which I got. So what was the Norton's current? Theoretically, I don't know, but practically I got the value of Norton current as 2.6833 for the same numerical. Rn was same 26.08 something, right? 089 ohms, and load current was how much? Simulated value 1.24811 amperes. This is ohms. Okay, so this has showed you how to do it simulated value. You can find the value of IN, RN, and IL. All right. So simulated value will be 2.6. You can verify it theoretically, solve the same numerical by Norton's theorem, but the final answer will remain the same. Okay. So in this way, we can find the value of, you can simulate any circuit and check its cross-check its value using LTspice software. One last piece of thing for maximum power transfer theorem. What is it? What we found out? What is that? What we find? Let's say we want to find the maximum power through 30 ohm resistance. Okay. So to find the maximum power to 30 ohm resistance, simulate everything and then just place the cursor over here near 30 ohm resistance. Can you see the bottom screen? Power dissipation 46.72 watts. So this is the amount of power we get it directly, maximum power. So in maximum power, that is the only thing we want to find the power max, and that will be available over here directly. Can you see this bottom window? Tool dissipation as 46.729, that will be the maximum power. So that's the only change we do it in the maximum power. Rest all the steps are remaining the same. Actually, maximum power is just all the steps for Thevenin's theorem only. At the end, we find P max. Okay, VTH square upon 4 RTH. So yeah, so that's all from my side. If you have any queries, you can ask me. Or else then that's it for this session. This recording will be provided to you all.